Hey Geometry, we are getting closer to finally finishing up chapter 10. We have this section and then one other section and we will be done. So towards the end of the week we will be reviewing because next Monday you guys have a chapter 10 test. So still some time to be asking those last minute questions on previous lessons that you didn't understand and to be asking me questions on these two lessons. I definitely think that the lesson that's in 10.6 is one of the lessons that you'll like. It's pretty easy. It's actually one of the easiest lessons, I think, in the whole geometry book. But let's get started with today's lessons. We're going to talk about some special segments that are inside of a circle. And we're going to start with a theorem. And this theorem says, if two chords, now let's talk real quick. What is a chord? Remember, a chord is a segment whose endpoints are on the circle. Does that segment have to go through the center of the circle? No. It can. If it does, that becomes the diameter, but it doesn't have to go through the center of the circle. The only thing we know about chords, the main thing you need to know, is that it is a line segment whose endpoints are on the circle. So again, that's just a vocabulary word from the very first section of the chapter. So knowing that vocabulary is important. Okay, so if two chords intersect in a circle, then the products, that means we're multiplying, the products of the measures of the segments of the chords are equal. Okay, it's very wordy, so let me break this down for you. Let's talk about chord number 1. It's broken into two pieces. We got a piece right here, AE. We have a piece right here. So piece 1 times piece 2, because it said product, so we're multiplying. Then we have another chord. And guess what? It is also broken up into, you guessed it, two pieces. Piece number 1 and piece number 2. And we're going to multiply them together. And those two products are equal. So when two chords intersect in, I'm circling that word, it's important. If they intersect in a circle, all you got to do is multiply the two pieces of one chord together and set it equal times you multiplying the two pieces of the other one together. So piece 1 times piece 2 equals piece 1 times piece 2. Pretty easy. Let's take a look at example number 1. We're going to follow along with what that said. So again, I've got two chords. This one is broken up into two pieces. Those two pieces are 8 and 6. So I'm multiplying them together. The other chord is broken up into two pieces, and guess what? We're going to multiply them together as well. So 8 times 6 is 48. 2x times x is 2x squared. What do we need to do next? Well, we need to get rid of that 2, so we're going to divide it over. So now I have 24 equals x squared. How do I get rid of a squared? Well, we square root. All right, let's talk about that. Is 24 a perfect square? No way, Jose. So let's talk about 24. 2 can divide into 24 12 times. 2 can divide into 12 6 times. 2 can divide into 6 3 times, and 3 is prime. So, do I have any pairs? You bet. We have a pair of 2's. I'm going to take out a 2. Did we have anything left? Yes, we did. We had a 2 and a 3 left over, and that turns into a 6. Will I include a plus or minus? No. Why not? Because in this case, x represents a distance, and a distance can't be negative. So this is my answer for number 1. Again, it comes down to doing piece 1 times piece 2 equals piece 1 times piece 2. All right, next theorem. So we're still talking about some special segments. This time, what are we talking about? We're talking about secant segments. All right, let's review what a secant is. A secant is kind of like a chord, except it doesn't have to stop at the end of the circle. So see how this is touching the circle twice? But it doesn't stop right here, it just keeps going. That's the difference between a chord and a secant. A chord stops at the edge of the circle. Secants don't. There's the only difference. Okay, So it says if two secant segments are drawn to a circle from an exterior point, that word's important, exterior point, then the product of the measures of one secant segment and its external secant segment is equal to the product of the measures of the other secant segment and its external secant segment. These theorems are so wordy, y'all. Let me break this down for you, make this easy. Notice that they have what's called an external secant segment. Well, that means the part that's on the outside of the circle. That's all that means, okay? So here's what this says we're going to do. We are going to multiply the whole secant. Whole secant. And we're going to multiply it times its external piece, okay? So I'm just going to call that outside piece. And guess what? We're going to set it equal to the other whole secant that is being multiplied times its outside piece. So if you look at the picture again, let's talk about it. SC, that's the whole secant, and then it's multiplied times SE, which is the outside piece. So whole times the outside. Same thing happens over here. SA, that is the whole times SN, that's the outside piece. So remember in the last one we just talked about, it says what happens if these intersect in the circle. This is what happens when they intersect outside of the circle. And so that's why this is a different formula. So you're going to have whole times outside equals whole times outside. That's what all of these words mean. So if you can remember this, that is so much easier than remembering those words. So whole times outside equals whole times outside. So let's look at example 2. All right, let's start with LS. LS is the whole, right? So what is the whole distance from L to S? Well, you have 4 right here. You have 9 right here. That gives us a total of 13. So we have 13 for the whole. Then we're going to multiply it times the outside piece. Well, LE is the outside piece, and it is 4. So we did whole times outside. Now we're going to do the same thing over here. So let's talk about whole. How do I go all the way from L to O? Well, it's just like over here. What did we do? We added 4 and 9 together. Same thing's going to happen over here. We're going to add the 3 and the x together, or maybe you want to write on your paper x plus 3. The order doesn't matter. Commutative property says that. So the whole piece is 3 plus x, and we're going to multiply it times the outside piece, which is 3. So follow along with me. We did whole times outside equals whole times outside. Okay, let's do some math. So 13 times 4 is 52. And over on the other side, I'm going to distribute the 3. So 3 times 3 is 9. And 3 times x is 3x. And I need to get rid of the 9, so I'm going to subtract it over. 52 minus 9 is 43. And then I need to get rid of the 3. So we're going to divide it on each side. 3 does not go evenly into that, so I'm going to leave it as a fraction. It's already reduced. Now let's go back and make sure we're answering the right question. Question says, use the figure below to find OG. Well, in the picture, OG is x. That means what we just solved for does in fact answer the question, and we are done. Okay, so to recap this page real quick, we said if you have these two segments and they are intersecting outside of the circle, that's where you use this formula. Whole times outside equals whole times outside. If you can remember that, these problems will be pretty easy. So let's try another one where we do the same thing. We want to do whole times outside equals whole times outside. Let's start with the top piece. What is the whole? Well, to go all the way across, we have to do 10 plus 11, which is 21. So the whole is 21. What's the outside piece? 11. So we did whole times outside equals. Now we're going to do the other side. First, let's talk about what would whole be. What do we have to do to get all the way from S to L? Well, you got to add the X and the 12 together. So our whole is X plus 12. What's our outside piece? It is 12. So we did whole times outside. Okay, so 21 times 11 is 231. Did I ever show y'all the shortcut for multiplying by 11 so that you can do it in your head? If I didn't, now's a good opportunity to hear it. Anytime you multiply a number by 11, and it's let's say a 2-digit number, you take these 2 digits, you add them together, and then whatever you get, you put it in the middle. So 2 plus 1 is 3, and it went right in the middle. Look at how fast that was, and I can do it in my head. Over here, we are going to distribute, so we are going to get 12x plus 144. So what needs to happen next? Well, we got to get rid of that 144. So I'm going to subtract it on over. That is going to leave us with 87 equals 12x. And then we got to get x by itself. So we're going to divide both sides by 12. Well, I can tell you 12 is not going to go into 87 evenly. What I can tell you is that both of those numbers are divisible by 3. Do you guys remember how to test if something is divisible by 3? If you add the digits together, 8 plus 7 is 15. Is 15 divisible by 3? Yes, that means 87 is also. So 87 divided by 3 is 29. 12 divided by 3 is 4. So there's our value for x. So let's go back and make sure we're answering the question. The question says find SL, and that means we haven't finished yet, because according to our picture, SL is the whole piece, and we said that that was x plus 12. So I'm going to take that x and plug it in. So we have 29 over 4, and we're going to add that to 12. But we need a what? We need a common denominator. So right now this is like a 12 over 1. I'm going to turn that into a 48 over 4 because I needed that common denominator. Remember, when you add fractions, keep your denominator the same. Add your numerators. So 29 plus 48 is 77. And that doesn't reduce, and so that can be our final answer unless you just have a hankering to turn it into a mixed number or a decimal. This is a great answer for your final answer. Okay, guys, so another theorem. Blah, blah, blah. It's a bunch of words, isn't it? Let me break it down for you. Okay, so where do these lines intersect? They intersect outside of the circle. That sounds awfully familiar, because a minute ago we had them intersecting outside of the circle, and what did we do? We did whole times outside equals whole times outside. Well, let's talk about that real quick. So a minute ago we did whole times outside equals whole times outside. All right, well, here you have the whole, that's EB, and then outside, that's ED. Okay, lining up, great. Whole times outside, got it. Look at the other one, EC. What is it? Well, it is definitely the outside piece. It's also the whole piece. So this same theorem works for this problem too. Again, why does it work? Because they are intersecting outside of the circle. So the same thing works. That's why EC is being squared, because it was the whole piece and it was the outside piece. So you're multiplying it times itself 2 times. So again, if you can remember this formula, because they intersected outside of the circle, then you have it made. Okay, that's what all those words are going to tell you. So if you can just learn this, this is going to be easy. So let's try it out. So here we are in example 4. Let's see what we have. So remember, we want to do whole times outside equals whole times outside. Let's start with this piece. What's the whole? It's 10. What's the outside? It's 10. Okay, we're done with that piece. Next piece. What's the whole? Well, got to add those two pieces together. So your whole is x plus 6. Or maybe you want to write 6 plus x, like I did. It doesn't matter. Commutative property says that order doesn't matter. So that's the whole. Now we're going to multiply it times the outside piece, which is just a 6. Ta-da! Same formula. Okay, so 10 times 10 is 100. Over here, I am going to distribute. So I'm going to get 36 plus 6x. I need to move that 36 over, so I am subtracting it. 100 minus 36 is 64. I still need to get x by itself, so I'm going to divide each side by 6. 6 does not go into 64 evenly. However, both of those numbers are even. That means they're divisible by 2. So 64 divided by 2 is 32, and 6 divided by 2 is 3. And that's our value for x. And now I want to go back and make sure I'm answering the question. It says find the value of x, which we have done. And so we are done. Okay. Oh, last example. Can you feel the excitement? Here we go. Example 5, last one. Same idea. We're going to do outside times whole equals outside times whole. Let's start with the one on top. What is the outside? It is 12. What is the whole? It is 12. All right. Other piece. What is the whole? Well, in the picture, they gave us the whole. Kind of looks that funny looking upside down mustache, if you will. There's our whole. And we're going to multiply it times the outside piece, which is x. So again, we did outside times whole, outside times whole. Here we go. 12 times 12 is 144. 16 times x is 16x. We're going to divide both sides by 16. Good news, 16 goes into 144 evenly. It goes in there 9 times. And the question said found the value of x, and we did it. So we are done. Okay, so real quick, before I log off, 2 main things you need to know. If your segments intersect inside of the circle, that's where you're going to do piece 1 times piece 2 equals piece 1 times piece 2. So where do they intersect? Inside the circle. What's the formula? Piece 1 times piece 2 equals piece 1 times piece 2. Now, what happens if they intersect outside of the circle? We have 2 issues. You might have a secant and a tangent, or you might have 2 secants, but it's the same because where are they intersecting? Outside of the circle, and their formulas are the same. Whole times outside equals whole times outside. So all you have to ask yourself is where are they intersecting? Inside or outside of the circle? If you can answer that question and come up with the right formula, then these problems will be a piece of cake. Whoops. All right, so we're done with the notes. Let's just real quick talk about this week. You guys have a homework assignment for this. It's in the book. Tomorrow you have another homework assignment. That one is a worksheet, so we're spending 2 days on this section. Then Wednesday we will do the last section. Like I said, I think you're going to like it. It is super easy. And then we will begin reviewing. So we'll be reviewing on Thursday. We'll do Zoom sessions and more review on Friday. And then your chapter test is going to be on Monday. So you have an entire week to get prepared for this chapter test. If you're not real happy with what your grade looks like right now, this is the best way to bring that grade up because tests count 60% of your grade. And so if you can do really well on this chapter 10 test, then you really can bring that grade up. So let's aim for that. If you have questions, shoot me an email and I will have another video up for you on Wednesday, and I will see all of you in our Zoom session on Friday. Talk to you in the next video.